Dear students, so if we remember what we discussed yesterday, that was something like urban ecosystem imbalance. We discussed urban critical zone. You remember? We discussed the anthroposphere and how urban critical zone is a subset of that. Then we discussed the dimensions of ecosystem imbalances, and we have discussed the measurement, how to measure this urban ecosystem imbalance, the key indicators. And that too we discussed for each one of these 6 dimensions. So today what we are going to discuss, we will be first starting with the understanding of urban ecosystem balance. So if it is a disturbed case, then how to bring back the balance. Thus the discussion in urban ecosystem balance. It's nothing like we are going to bring it back to the pristine ecosystem. No, we would like to see how to continue with the urban activities and then to also bring in good relation or good working relation with the ecosystems. Then we will be discussing the dimensions of ecosystem balance. Those 6 dimensions only we will bring back, and we will check them, not only what the concepts are, but also we will check with the good case studies, both from the global scale as well as the national scale. So, what is urban ecosystem balance? Definition wise, the urban ecosystem balance can be interpreted as a multi-dimensional equilibrium emerging from the interplay of biophysical, ecological, chemical, socio-ecological, socio-economic, institutional, and temporal processes. All the dimensions which we have already mentioned when we discussed the imbalances. Urban ecosystem balance and imbalance are two states of the same dynamic system. What constitutes balance within urban ecological systems? Let us see that. While imbalance reflects stress, disruptions, disturbances, or deviation from sustainable functioning, there the balance represents a dynamic state of co-functioning among natural and human systems within cities. So that is very important to note the term dynamic state. We are not expecting that it is reaching a static relation. Urban ecosystem balance can be achieved and we can understand and we can intervene accordingly. So achieving this balance requires maintaining environmental quality and functional biodiversity, which will come under the bracket of biophysical and ecological balance. Then regulating material and chemical flows within the assimilative capacity of the local environments, which we have discussed under the biogeochemical balance, those cycles, and enabling co-adaptive human-nature interactions. Co-adaptive and co-shaping, that relation has to be ensured. And how we can do that? Through inclusive and accountable governance. So it will take care of the socio-ecological and institutional balance. So that's the way we can bring back the urban ecosystem in a balanced stage. Persistent imbalances such as intensified urban heat island, which we have already discussed, altered hydrology, or unequal access to green space, which is actually reflecting the social aspect, and reducing adaptive capacity and increasing vulnerability to climate related shocks. The challenge is transitioning from the accumulated ecological stress toward a resilient equilibrium that will facilitate ecosystem functions and human well-being. So, what is the central question? Once we understand that imbalances are persistent in the urban areas, whereas we know that there is a good target of ecosystem balance, then the question is how to do that? How do we transition from a state of imbalance, which may be critical also in many cases, to one of the dynamic ecological balance? So, we will look at that. This transition, how we can really get it happened. The notion of urban ecological balance does not imply a static equilibrium, but a dynamic and adaptive harmony, a condition where ecological processes, built environment functions, and human well being reinforce one another rather than compete. That is very important concept. How we can do it? Inclusive planning, resilient infrastructure investment, well planned urban forms, expanding blue green infrastructure, and strengthening local governance capacity to manage land, resources, services, and equitable access to public space help reduce the environmental pressure. Whereas it will also support social well being, it will enable the cities to absorb shocks and to reorganize without losing the core functions. This is a known slide. Only in last class we have discussed these 6 dimensions of ecosystem imbalances. Which are these dimensions? Biophysical, ecological, chemical, socio-ecological, economic, institutional, and temporal. To move from this ecological stress condition toward resilient urban functioning, each of the 6 dimensions we discussed earlier must shift from the threshold exceeding conditions toward the states which are balanced, where each dimensional processes operate within safe and regenerative limits. So, thus the way we can have the ecosystem balance from the ecosystem imbalance state. Let us see each one of these dimensions one by one. Biophysical balance, a balanced biophysical state is achieved when urban land cover, microclimate, and hydrological flows function within local ecosystem capacities. Vegetation structure, soil permeability, and surface temperatures remain stable, reducing flood risk and heat stress while supporting habitat quality. So, whatever is getting generated due to the urban form, urban morphology, can we manage it locally? That is going to be a very important way to bring back the biophysical balance. Most of the things can be managed to a great extent, even if not entirely. Ecological balance. This urban ecosystem balance exists when species diversity, habitat connectivity, and trophic interactions are maintained. Thus, they allow ecosystems to regenerate naturally. So, what are the conditions when you can say that ecological balance is existing? When native species thrive, invasive species are controlled, urban green spaces sustain pollination, nutrient cycling, and carbon sequestration, and urban blue spaces maintain balance. So, you can easily understand here that we are also discussing not only the structural components but also discussing not only the abiotic components of structural components of ecosystem but also the biotic part. Both the components shall be present and both will have their own regenerative capacity naturally, need not to really have input from society. So, that's the way ecological balance of an urban ecosystem can be maintained. And also another thing is important, that connectivity, habitat connectivity, that is very important, which is actually having facing lot of challenges in urban ecosystem, that connectivity. Though species diversity we have seen it is enormously present. Next dimension we'll be discussing is the chemical balance. It occurs when air, water, and soil contaminant levels remain below ecological and public health thresholds. Unlike Delhi's air pollution dashboards, where we can see always it is in the severe condition, almost always. Today also there was a discussion on that, which I brought last time as well, that this particular whatever air components are good for health, that has to be maintained. That is part of the chemical balance. Waste streams are safely treated, including the water streams. Nutrient loads are regulated and industrial emissions are minimized, thus enabling the environment to assimilate pollutants without degrading ecosystem function and quality of living experience. Now we'll be discussing the fourth one, the socio-ecological dimension. And a balanced socio-ecological state ensures equitable access to ecosystem services such as green space, clean water, and climate regulation, so that their mental and physical well being is being taken care. How to ensure that? Through participatory and accountable governance. There shall be a monitoring process as well, not only providing the spaces but also checking how those spaces are being utilized, how those facilities, amenities are being utilized, whether everybody, especially the vulnerable section, is getting access to those or not. That is very important. Institutional coordination supports the community stewardship, conflict resolution, and adaptive planning. Next dimension we'll be discussing is the economic institutional balance. Economic balance is achieved when development processes internalize environmental cost. So they accept this intangible environmental cost and act accordingly. Not that they try to put it under carpet. Even if they are not tangible, you have to discuss it because we know that is going to happen. So that is very important, that we internalize environmental cost. We incentivize low impact design. If some sections, certain neighborhoods are doing good job, they should go get some good recognition, like incentives, like they can be awarded in different ways, and allocate resources towards ecological infrastructure. So that is also a very strong paradigm shift. Ecological infrastructure, towards that also we should really have our resource allocation. Institutions align economic growth with sustainability, and thus they prevent overconsumption of land, water, and energy. So the role of institution in this balance, urban ecosystem balance, is really very important. The last one we will be discussing is the temporal balance. It exists when urban planning anticipates long-term environmental change and manage the lag effects and maintains ecosystem services for future generations. And if we remember the very well accepted definition of sustainable development, that talks about the future generation. Monitoring, scenario planning, and adaptive cycles, they allow systems to reorganize after disturbances without losing core functions. So, with time, the changes, is it going to help or is it going to bring disturbances? These things needs to be managed and the feedback loop shall be always active. That is important here. So now we have discussed all the dimensions, all 6 dimensions towards the urban ecosystem balance state. Now we'll be discussing some very interesting case studies, and we will look at these dimensions through these case studies. And for our own interest to be served, we selected the case studies both from the global scale and also from the Indian cities. And in each one of them, you have to note these balances from 4 different aspects, 4 different lenses rather: biophysical and ecological balance, biogeochemical balance, socio-ecological balance, and institutional balance. So, first set of case studies are coming from the biophysical dimension. And first, I will be discussing the global cities, and then I will come for the Indian cities. And this pattern I will follow till the 6th dimension. So, first case study I chose is from Singapore. Through its active, beautiful, clean waters, ABC Waters, that's the program name. Through that program, Singapore restructured its stormwater and drainage systems to function as a living waterways integrated with urban landscapes. And this particular program balances urban runoff with groundwater recharge and biodiversity. So now runoff is not an waste, runoff is an wealth, and it is helping the groundwater recharge and helping in biodiversity. Thus, it is reducing the risk of flooding while it is also improving the thermal comfort. Similarly, we can look at Copenhagen, the cloudburst management plan. In today's time, I think every alternate week we keep on hearing cloudburst in many places across India. Just see, in 2012, Copenhagen took that particular phenomena seriously, and they have a management plan which has restored biophysical equilibrium. How they have done that? They have created multifunctional blue green corridors that store excess rainwater. So, that particular cycle of hydrological cycle is being properly maintained even in the city. That has been ensured. So, continuous supply of moisture through evapotranspiration, that is there, and also ground is getting the supply of water. So, while also it is helping cooling the city and also soil water interaction, it is taking care of that cloudburst. So, this is a very interesting case you can see from the biophysical dimension. Third case study from the global city, I have selected Melbourne. Its urban forest strategy enhances biophysical stability by linking canopy cover and evapotranspiration to urban cooling, soil moisture, and atmospheric regulation. So it's a 20-year plan. So it's not like a short term. Today I do something and tomorrow I expect the result. No. 20-year plan, it aims to increase canopy cover from 22% to 40% through planting 42,000 trees and improving species diversity and vegetation health. So you just see how differently different cities are having their contextual problem being solved and bringing the ecosystem balance back. Let us see from the Indian cities. Balancing the physical metabolism of the city is the major function of this biophysical one. In Chennai, the integrated stormwater drain and lake restoration program that connects macro and micro drainage networks, and they are connected with the restored water bodies. So, thus, it's like a net all over the city, and it is re-establishing the pre-urban hydrological balance, which is really ambitious and very much necessary for the city. It enhances infiltration, groundwater recharge, and flood regulation. And definitely cooling impact it is adding. Next example is Ahmedabad. All of us we know about the Sabarmati riverfront development, but probably we know only about the phase 1 because we discussed that mostly. But phase 2 is a revision. What we could not gauge, understand in the first phase, that concretization is not going to help us, that has been revisited. Now, phase 2 is now emphasizing ecological flow maintenance, reducing earlier hydrological imbalance which was created by the concrete embankments. So, just see the changes. You can correct also your activities. In Pune, we see another very interesting mission program, that is the Urban Biodiversity Parks. This initiative restored the local topography and soil water interaction on degraded hill slopes, stabilizing the runoff and temperature regulation function. Now we come for the next dimension, that is the ecological dimension. First is the Berlin example. I think many of us, we have already heard Berlin biotope factor. This biotope area factor is nothing but like our building bylaws, where it is compulsory that any new development need to have a very strong biologically active space, and any old structure, if they come for any reconstruction or even they are doing maintenance job, then also they have to add some biologically active spaces, but there the ratio is less. So it's a beautifully balanced techno-legal tool, you can say. So that regulation is a wonderful tool. All of us, we can have a good look at it. It ensures minimum ecological functionality per land parcel. Each land parcel need to take this responsibility to have certain portions which is ecologically active. This preserves pollinator networks and soil biota even in highly urbanized zones, and they help as a stepping stone, keeping the contact, the connect corridor. That is very important. In the New York City, what we see, Million Trees New York City initiative, which restored native species composition and re-established ecological corridors linking park system, thus rebalancing food webs and habitat diversity. The last one is another global metro, that's the Tokyo, which is using Satoyama principles in its urban peripheries, because within the urban area there is no such land, but at the periphery they are doing this experimentation, integrating agricultural and forest patches that maintain ecological flows between the built up and natural areas. It's a wonderful principle. All of you can look at it. How the mixed, there shall be some grassland, there shall be some agricultural land, forest land, human beings are staying there. All of them are happening just next to each other and supporting each other, and ecological flows are happening. That's a wonderful principle. One takeaway from this particular slide, I think all of us we can take, that is, if cities like Berlin, New York, Tokyo can do, which are so heavily pressurized from global demand, then probably every city can look at the opportunity. So let us see what Indian cities are doing to maintain habitat heterogeneity, species diversity, and functional linkages. First one we will pick up from Delhi, the Aravali Biodiversity Parks. Sanjay Van, Jamuna Biodiversity Park. They are reintroducing native species and creating stepping stone habitats. Do you remember keystone species? Just go back and look at it. Stepping stone is completely different from keystone species. Stepping stone means it's a connector. I am having small patches so that there will be some biological and ecological activities, so that the live biotics can hop from one stepping stone to the main habitat or to another stepping stone. That's the way the connection will be continued. So, these stepping stone habitats within the dense urban matrix, they act as self-sustaining ecosystems, balancing trophic waves and groundwater regimes. All these things we have discussed initially when we discussed the natural ecosystem. Second example is from Hyderabad, which is recognized as a UNESCO Tree City of the World. The city's Harita Haram program has integrated urban forestry with ecological corridor development. Another very good example is from the Bangalore, where we see the assets lakes that are now getting rejuvenation scope. So this lake rejuvenation network and adjacent green belts, they are reconnecting fragmented wetland forest systems, and it is helping in rebalancing habitat connectivity and nutrient cycles. Now we will come to the chemical dimension. The global example is from Stockholm. Implements closed loop nutrient systems by reusing wastewater sludge for biogas and fertilizer production, reducing chemical imbalance in soils and waterways. What Zurich is doing? It is enforcing strict urban air quality and carbon neutrality targets, supported by electric mobility and building retrofits to reduce chemical load in the atmosphere. In the Seoul, we have another wonderful example, champion example, we can say, through Cheonggycheon stream restoration. Chemical contaminants from surface runoff were reduced by restoring the natural filtration process and microbial balance in sediments. We will come back to this particular example probably again and again. It's a wonderful case. And in Indian cities, we see to address this imbalance in carbon nitrogen pollutant flows through circular approaches are quite evident. The cities like Indore, what Indore has done, India's leading solid waste and wastewater management city, now recovers compost, biogas, and grey water from municipal waste streams, closing the carbon nutrient loop. And continuously, they are getting acknowledged for their this particular effort, sincere effort. What Delhi NCR is doing, the odd even vehicular scheme, which was only for certain days, it was working very nicely, and smoke towers. They represent interventions to chemically rebalance atmospheric load. That it is doable. At least we can reduce the load to a great extent. While not sufficient alone, they highlight regulatory attempts to manage NOxes, SOxes, and PM levels. In Pune and Surat also, we see similar efforts promoting decentralized wastewater treatment (DWATs) and nutrient recycling, reducing eutrophication and soil contamination in the downstreams are the impact of those initiatives. We will come to the fourth dimension now, socio-ecological one. The examples are Portland, Oregon from USA. It's a community-led green infrastructure program, such as Green Streets that promoted co-management of biosoils and rain gardens. And thus they strengthen the local stewardships of ecosystem services. This is very important, community participation. Other than that, you cannot maintain that balance. You can create that balance, but it's a dynamic one. You have to maintain it also. In Curitiba, urban planning played a havoc role. It integrated ecological parks. How? As flood buffers, not only as amenities but also as flood buffers, reflecting a deep social ecological connect that values nature as infrastructure. In Seoul, what we have seen, residents are participating in transforming elevated expressways into green corridors, rebalancing human environment interaction while enhancing quality of life and public health. Just in the previous dimension, I was mentioning in the under ecological that Cheongyecheon, actually there was an elevated expressway. So residents they agreed to bring it down and to re-bring that stream to the public. From the Indian cities, what we see co-production of ecosystems through community engagement and behavior. In Bengaluru, citizen-led lake groups like Jakpur Lake Trust, Puttanahalli Neighborhood Association, they manage lakes through participatory governance, ensuring ecological maintenance and community ownership. This is going to have a very strong opportunity for successful intervention because people are there. In the Aizal, in Mizoram, we see that they integrate traditional hill slope cultivation, Jhum cultivation of Northeast. That transitions with urban green zoning, maintaining cultural and ecological balance between human livelihoods and the forest regeneration. Let us now come to the south. In the Kochi, what we can find, the Cochin Smart City Mission. It has a particular program, backwater restoration. And this engages fishermen community and the local community to co-manage mangrove fringes, and thus they link livelihoods with the ecosystem health because they are the people who understand firsthand that what are the benefits these mangroves are going to bring to them. So that way they are very, very interested, and hopefully this mission is also going to bring success. Now we will be coming to the fifth dimension. The discussion will be on economic institutional. The first example is from London, the natural capital accounting system. It's a technology, ecology, everything together, that understanding, science understanding, that integrates ecosystem valuation into decision making. Thus, it ensures balanced trade offs between development and ecological assets. In Amsterdam, what we find? The circular economy strategy that uses the material flow, accounting, and waste minimization. You remember that urban metabolism we discussed? This is part of that only. Waste minimization, and that targets to close resource loops, bringing material and economic balance together. And the last example for this particular economic institutional dimensions will be from the Vancouver, the global example. The Greenest City Action Plan they had instituted. And through this, the low carbon economy, which will transition, which will bring transition, and that will be monetized ecosystem services and internalization of environmental cost. So they are not forgetting the social need, but they are also addressing the ecological need through the economic tools and institutional tools. Now we can see that Indian cities are also embedding ecological value in economic and institutional decision making. Some examples like Pune, they introduced green budgeting, allocating funds to projects that improve ecological assets and institutional mechanism for environmental accountability. In Delhi, we see the local biodiversity strategy and action plan, which aligns economic planning with biodiversity targets through decentralized committees under Biological Diversity Act. In Surat also we see that Asian Cities Climate Change Resilience Network. Through this network, Surat has developed a climate resilience strategy which integrates industry and flood and public health systems that reflects institutional balance between economy and ecology and society as well. Last dimensions in this ecosystem balance discussion will be temporal one. And the global example of Rotterdam fits very well. Its climate adaptation strategy explicitly integrates temporal foresight by designing adaptable water plazas and flexible flood infrastructure that evolve with changing sea levels. See how the science is helping in urban planning. What Singapore has done, it is using the long term scenario planning for land water biodiversity balance, and it is updating its strategies every decade in line with shifting climatic and demographic realities. These are intelligent moves. In Paris, through Plan Climate Energy, the city tracks temporal trajectories of energy emissions and green cover to maintain balance between current needs and future ecological stability. So, not only cities are bringing ecosystem balance, the dynamic one for today, but also trying to do it for the future, keeping future in mind. Same about the Indian cities. Long term adaptive management, intertemporal balance, and resilience thinking we can find in Indian cities as well. What Mumbai has done, the Coastal Road Project, that attempts adaptive design revisions, tidal exchange tunnels, mangrove buffers to integrate temporal ecological feedback into infrastructure planning. That's a smart way to go. What Bhubaneswar has done, the name itself is the Smart City and Resilience Strategy. So, what is there in this strategy? The strategy is aligning with 100 resilient cities. Rockefeller Foundation took this initiative, that framework, embedding flexibility and scenario based planning for climate ecosystem balance. So, you are taking advantage of today's updated technology, computational power, and visualization capacity. And then you are doing so many things now. In Guwahati, we see under NABARD and GIZ supported climate resilience projects, wetland rejuvenation and hill slope afforestation are framed as adaptive multi-decadal strategy to balance future hydrological extremes. So that's the way also the future is being taken care in today's time. So we discussed ecosystem balance concept and we have seen the dimensions through different case studies globally as well as nationally. So these are the reference lists. Thank you.